Digital Signature Algorithm. What is DSA algorithm? Digital Signatures Algorithm is a FIPS or Federal Information Processing Standard. For digital signatures, it was proposed in 1991 and globally standardized in 1994 by the National Institute of Standards and Technology or NIST. It functions on the framework of modular, exponentiation, and discrete logarithmic problems which are difficult to compute as a force-built system. DSA algorithm provides three benefits which are as follows. Number 1. Message authentication. That you can verify the origin of the sender using the right key combination. 2. Integrity verification. You cannot tamper with the message since it will prevent the bundle from being decrypted altogether. And the last one is non-repudiation. The sender cannot claim they never sent the message if verifies the signature. The image above shows the enterprise procedure of the DSA algorithm. You will use two different functions here, assigning function and a verification function. The difference between the image of a typical digital signature verification process and the one above is the encryption and the description part. They have discrete parameters which we will look into the next section of this lesson of the DSA algorithm.
Steps in DSA algorithm. Key generation. You first choose a prime number q which is known as the prime divisor. Another prime p is chosen such as the p1 mode q equals 0. So choose an integer g1 less than g less than p, satisfying the two conditions g and q mode p equal 1 and g equal h multiplied by p1 divided by q mode p. So x is our private key and it is a random integer such as that 0 less than x less than q. Y is our public key and you can calculate it as y equal gx mode p. Now the private key package is p, q, g, and x. The public key package is p, q, g, and y. Signature generation. It passes the original message capital M through the hash function capital H sign number to get our hash digest small h. It passes the digest as input to a signature function whose purpose is to give the two variables as output, S and R. Apart from the digest, you also use a random integer k such that 0 less than k less than q. Next, to calculate the value of R, you use the formula R equal G K mod P mod Q. To calculate the value of S, you use the formula S equal K1 H plus X and capital R mod Q. It then packages the signature as R and S. The entire bundle of the message and signature, capital M, small r, and S, are sent to the receiver too.
Step in DSA algorithm. 3. Signature verification. 1. you use the same hash function, open parenthesis, h sign number, close parenthesis, to generate the digest h. 2. You can then pass this digest of the two verification function which needs other variables such as parameters 2. 3. Compute the value of w such that s sign number w mode or mod q equals 1. 4. Calculate the value of b1 from the formula b1 equals h sign number w mode q. 5. The final verification component b is calculated as b open parenthesis gu1 to y v2 close parenthesis mode p to mode q. Then the last, it is compares the value of b to the value of 1 received in the body.
Highly robust DSA is highly robust in the security and stability aspect compared to alternative signature verification algorithm. Better speed, the key generation is much faster compared to the RSA algorithm and such.
Advantage of DSA or the digital signature algorithm: less storage. DSA requires less storage space to work its entire circuit. Patent free. When NIST or the National Institute of Standard and Technology released, it was patent free, enable its global use free of cost.